Hello everyone, and welcome to my retro programming channel. Today, a little special video, where I'll try to create my first cartridge, my first CRT file, to run in the Vice emulator. So, I went to look for documentation on the Codebase 64 website to see how cartridges work. A cartridge starts with a header, which explains what data will be inside, depending on the type of cartridge you're working with. Cartridges start in memory at hex 8000 and use an 8 kilobytes bank system. Some are 4 kilobytes, but most are 8 kilobytes. I think there's only one that is 4 kilobytes. It must be the normal cartridge in Ultimax mode. We're going to focus on a simple cartridge, the standard, the regular one. So, there's already a header that starts with C64 cartridge, as you can see here. And it's followed by spaces, the character 32. This part isn't difficult to do and it's always the same. So, we're just going to copy this. Next, the header size, which is supposedly 32 bits, although its size is only 64 bytes. So, we have 3 zeros followed by hex 40, still in hexadecimal. After that, we have the version. It should always be 1.00, so hex 01, hex 00. Then, the type of cartridge, and for me, I'll use the standard, the normal cartridge, so it's also 2 bytes, and it will be 0. Then, XROM and game, which depend on the cartridge type. As I mentioned, I'll use the regular cartridge. So XROM should be 1. Sorry, the one with 8 kilobytes. With XROM set to 0 and game to 1. If I go back here, so I was here. Next, followed by an empty area filled with zeros. And finally, the cartridge's name will be the next 32 characters, which correspond to the name of the cartridge. After the CRT file header, we can have multiple data banks. Since I'm using the standard, I'll only have one 8 kilobytes bank. Its header is here, starting with CHIP. And then we'll see how it works. The constant chip, CHIP. Then the bank size added to the header size. And followed by the type of chip. Normally, a cartridge must be ROM. But it could potentially be flash ROM. Though I don't think that's in the list here. And finally RAM. I haven't found any documentation on these last 2 chip types for now. I'll see later if there's documentation anywhere. After that, the bank number. The startup bank is always bank 0. And I suppose that chip elements in CRT files are ordered from 0 to N. This bank 0 will be located at the startup address, the starting address. So here if I look at this cartridge, it starts at hex 8000, and finally, the size of the bank itself. We've seen that it's 8 kilobytes, so hex 2000. So, you'll notice that for both the file header and the bank header, sizes are given in Big Endian, meaning the most significant byte comes first. And this is also true for the 32 bits values. That's okay. Well, what I'll do is write a simple program that will just change the background color. It'll only do that, it's just for testing purposes. To do this, I created an empty folder, there's nothing in it, and I used the HXD application. It's a free hex editor, nothing special, and I'm going to start by creating my header. So, here's the header, I'll copy it here. Create a new hex file, and paste it. Now that I've created a cartridge, I'll widen the view a bit to see what's written, and there I've created my first cartridge. Next, I need the size of the header, so the header size will always be 64, so hex 40, and the version is always the same. So I'll add the size of my header, the version of my cartridge. Then for the type, I'm using the normal cartridge, so it will be type 0. Hex 00, hex 00, to define the cartridge type. Next value, XRAM. For the normal cartridge type, XRAM should be inactive. And I believe game, which comes right after, should be active. So, that's done for XRAM in game. Now, some empty data's reserved for future use, so we'll complete that with zeros. And, finally, the name of my cartridge in uppercase, I'll call it test cartridge. But I'll write it here. And for the remaining space, I'll fill it with zeros, so I'll go back and add zeros. And there we go, I've got my header. I'll save this, test.crt. Save. And my file should appear here. There it is. So, CRT files are security certificates on Windows, which is why I have this icon. Good. Now, my first data bank. It starts with chip, so here we go. Here, I'll write CHIP. And then I'll add the total data packet size. For now, I'm not sure what this will give, so I'll put FFFF, that'll be easier to spot. The chip type will be ROM, so its value 0. The bank number is the first one, so 0 as well. And then I need to specify the starting address. If I go back to my cartridge type, the address is hex 8000. So here, I'll put hex 8000 and... No, I'm not in the right place for the starting address. I must have forgotten something. Okay, the total packet size is actually 32 bits. There we go. Okay. The starting address, which I just set to hex 8000, so it's not correct, I must have forgotten something. Bank number, that's what I forgot. So, Hex 8000 is the address and then the size of my image. For now, I'll leave it blank with FFs. I'll save it. And now, I need to add the program, what's really on a Commodore 64 cartridge. So, how does a cartridge work? A cartridge must also have a header in the Commodore ROM. The reset of the machine points to FCE2. It checks here if there's a cartridge signature at hex 8000, meaning if we have a cartridge. If I look here, it checks if I have 5 characters from hex 8004 to hex 8008 that it will compare with FD10 to FD14. It's referenced here. I must have CBM80. What you need to know is that at the beginning of the cartridge, there are 4 values, and then it must be signed CBM80, which corresponds to 5 characters plus 2 locations that correspond to the cartridge's jump start. The first 2 bytes are used here for a jump at hex 8000. This corresponds to the cold start of the Commodore. And then we have the warm start point. Since we're now in the Commodore ROM, and not in the CRT file header, we work in Little Endian, meaning the least significant bytes come first. So, we'll put hex 80 and hex 09, since we can start our assembly program here at hex 8009. I'll do the same for the warm reset. And from here, I can add assembly code. I save it, and now, I'll put a small assembly code here. So, I'll write this. I'll increment the border color and do another jump at hex 8009. I assemble it. I check the generated code and copy it here. Now, I know the size of my data, so I'll have 16 plus 15. So my total size will be hex 001F. And here, the size of the code will be 0F. I save it. And I cross my fingers. I start an emulator. Drag the cartridge file and it doesn't work. So, where did I go wrong? That's an excellent question. Here, the version. Xrm is inactive. Game is active. After that, it's fine. Test cartridge, that's my cartridge name. Well, since I don't know what happened, I'll launch the monitor. Okay, so my windows are here, and I'll go back to the cartridge. So, what's going on? I compare, so far so good here. I'm checking my CBM80 and in fact, the CBM is wrong. It's probably wrong because I didn't pick the right text. Here, it compares with hex FD10. Okay, and just after C3 C2 CD 3830, and what do I have? I have 3830, but I don't have C3 C2 CD. Alright, I'll fix it and try again. Oops, the monitor is still active. I'll close it and go back to my cartridge. Ah, here we go. That was it. It didn't recognize it was a cartridge. So, here's my first cartridge. It's not super complicated, actually. I think I'll be able to use this to create little things on a cartridge. We'll see that later. In the meantime, thank you for watching this little video. I hope it taught you something. For me, at least, it taught me a lot, and I really wanted to try this live with you. So, of course, you saw I did some tinkering. It's true that I read the documentation before making the video, but I hadn't tested it yet. If you enjoyed the video, don't hesitate to give it a thumbs up. Also, don't forget to subscribe to the channel so you don't miss the next videos. All that's left for me is to wish you a great end of the day. Take care.